Okay, this is video is going to show you how you go ahead and set up and balance a chemical equation. So the steps will be illustrated as I go through it, and you can follow along again. Okay, on this first example, we have an equation that says that we have zinc plus sulfur will give you a compound called zinc sulfide. So the first thing we're going to do is we're going to turn everything into chemical symbols. So the symbol for zinc is Zn, plus the symbol for sulfur is S. Don't forget to write out the yields arrow and the plus sign. And then we have a compound, zinc sulfide. So this is our binary compound. So I look up on my oxidation table and I see that zinc is +2. The "ide" ending means sulfur. Sulfur is -2. Since the two oxidation numbers add to 0, I can just put the two symbols together. Now the next thing I'm going to check here is for just plain elements, are they on that list of diatomic elements that I gave you? And zinc isn't and sulfur isn't, so you just write them as the plain symbol. Then I'm going to start to count. I notice that I have 1 zinc on the reactant side. I have 1 zinc on the product side, so it's okay. I have 1 sulfur and 1 sulfur. So this equation is said to be balanced. Okay, so on this problem, we have a compound hydrogen oxide plus another compound hydrogen chloride will give me a compound sodium chloride plus a compound hydrogen oxide. So the first thing I do when I'm having to write out compounds is I'm going to look up their oxidation numbers. So sodium will be +1. Hydroxide is polyatomic, that's -1. Hydrogen is +1. Chloride is -1. Sodium is +1. Chloride is -1. Hydrogen +1. The oxide is oxygen, so that's -2. And then I can write out my binary compounds. So since those two add to 0, they just go together. NaOH plus hydrogen chloride, HCl, will give me sodium chloride, NaCl, plus, this one I have to cross, so that'd be H2O, water. Now what I'm going to do is I'm going to count. Now my rule that I have here, I have a little rule that you want to follow. The rule is do hydrogen DROGEN last. You want to do hydrogen last. So I'm going to start with sodium. So sodium, I have 1, I end with 1, it's okay. Oxygen, I have 1, I end with 1, it's okay. Chlorine, 1, I end with 1, it's okay. Now hydrogen, I have 1 plus 1 is 2, and I end with 2, so it's okay. So this equation is balanced as written correctly. So I just write the word balanced right there. On my next one here, I have an equation. I have a compound, ammonium nitrite, plus nitrogen gives me a compound, hydrogen oxide. So again, with compounds, I go through and I get the oxidation number. So ammonium is +1, nitrite is -1. Nitrogen's an element, so we don't need to do its oxidation number. Hydrogen +1, oxide, again, is oxygen, so that's -2. And then I can write out the formula. So ammonium is NH4, nitrite is NO2, they just go together. Nitrogen is N, and hydrogen oxide I have to do a cross. Now the thing I have to check, since I have just a single element, I look on that diatomic list, and nitrogen is on the diatomic list, so we would write it as actually N2 when it's totally by itself. It's not part of a compound. We just write it out as N2. So now that I've got things written correctly, I can start to balance. And again, remember, my rule is I always count hydrogen last. So we'll start with nitrogen. I got one nitrogen here plus another one there. So there's 2, and I have 2. That's okay. I have 2 oxygens there, but I only have 1. So I need 2. So I'm going to have to balance it by putting this number in, and that's called the coefficient. And it goes before whatever oxygen's attached to. You can't stick it behind, and you can't stick it in between. It has to go in front of whichever compound it's attached to. So it has to go in front. So now I have so what it says is I have 2 times 1 oxygens. But now notice what it did to my hydrogens. I have 2 times 2 is 4. And then over here, if you notice, I have 4. So hydrogens fix themselves. So this one now is balanced. On the next example, I have iron, copper nitrate, copper 2 nitrate, gives me iron 2 nitrate plus copper. So again, for the compounds, iron is an element, so I can just write down its symbol, Fe. But for the compounds, I need to go through the oxidation numbers. So copper 2, that means it's going to be plus 2. Nitrate is minus 1. Iron 2, that would be plus 2. Nitrate's minus 1. And copper is an element. So when I'm looking at this, I'm going to write out so that would be Cu, and I need NO3, but I need 2 of them, so I have to put it in parentheses. Then I have Fe, NO3, and again from the cross I need 2. So those are written correctly. Now the other thing I check, since I have a single element here, I need to check to see if it's on the diatomic list, and iron isn't, so I just leave it as Fe. And copper over here, the same thing. It's not on that list, so I leave it as Cu. So now I can count. I have 1 iron, I have 1 iron, it's okay. I have 1 copper, I have 1 copper, it's okay. Nitrates, and I look at them as just a unit, NO3s. How many NO3s do I have? I have 2, and I end with 2. So this equation would be balanced. On number 5, I've got a compound, barium chloride, plus a second compound, sodium sulfate, gives me another compound, barium sulfate, plus a 4th compound, sodium chloride. Since they're all compounds, I got to look up all their oxidation numbers. So I look up barium is plus 2, chloride, mean chlorine, is minus 1, sodium is plus 1, sulfate, polyatomic, but it's minus 2, barium was plus 1, sulfate was minus 2, sodium plus 1, chloride is minus 1. So now I can write out their compounds. So barium is Ba, chloride is Cl, and the 2 comes down from the cross. Sodium, Na, the 2 comes over, and sulfate is SO4. Barium again was Ba, sulfate, barium was plus 2, excuse me, up there. And sulfate is minus 2, so it'd be SO4. They just go together, plus sodium chloride, which would be NaCl. So now, since I've written them all correctly, I can start to count. And again, the rule is hydrogen's counted last, but there's no hydrogen there, so we don't have to worry about it. So we've got 1 barium, 1 barium. It's okay. Chlorine, I have 2 chlorines, but I only have 1, so I need 2. So I'm going to use that coefficient number, and it has to go in front. It has to go in front of the sodium. It can't go behind the chlorine. It can't go in between. It has to go in front. So they're okay. Now I have 2 sodiums here, and now look, I have 2, so they're okay. And then sulfate, the group of sulfate, SO4, I have 1 group, and I have 1 group. So now that equation is balanced. In this example, we have lead 2 acetate compound, hydrogen sulfide, another compound. We have lead 2 sulfide and hydrogen acetate. So they're all compounds, so I need to get their oxidation numbers. The 2 here means it's going to be plus 2. Acetate is minus 1. Hydrogen is plus 1. sulfide element, sulfur, is -2. Lead was +2. Sulfide was -2. Hydrogen +1. And acetate was -1. So now that I've got them, I can write it all out. So lead was Pb. Acetate, C2H3O2. And then it's got to do a cross, so I need 2 of them. Got to put it in parentheses. Plus hydrogen sulfide, which would be H2S. Produces lead 2 sulfide, that would be PbS. Plus hydrogen acetate, HC2H3O2. So now that I've got them written right, according to the oxidation rules, I count. I got 1 lead, 1 lead. That's okay. Acetate groups, I have 2. But here I only have 1 acetate group, so I'm going to need 2. That means, yeah, I have to use that coefficient number, and it's got to go in front of the H. Now I have 1 sulfur, and now I can count my hydrogens since I do it last. I have 2 hydrogens here, and now I have 2 over here because of the coefficient. Hydrogens always fix themselves, so now this one is balanced.